Welcome to NJP Online Mathematics. Let's solve this lovely thrilling problem together. We are going to determine the value of x in this equation here. We are having 2 to the power of x minus 1 plus x divided by 2 equals 3 multiplied by x to the power of 6 minus 2 to the power x minus x. All this is the exponent of x, and we are to determine the value of x in this equation. So let's give the solution to this problem. We are having 2 to the power of x minus 1 plus x divided by 2 equals 3 multiplied by x to the power of 6 minus 2 to the power of x minus x, and we are going to determine the value of x in this equation. We have to recall some certain law of exponents, that if we have a to the power of m plus n, that this is the same thing as a to the power of m multiplied by a to the power of n. This is the addition law of exponents. We have to recall also that a to the power of m minus n equals a to the power of m divided by a to the power of n. So we are going to apply these laws of exponents here by simplifying this to determine the value of x. So let's apply these laws here to solve this problem. We are having on the left hand side of this equation 2 to the power of x minus 1. So applying this law, we are going to have 2 to the power of x divided by 2 to the power of 1 plus x divided by 2 equals 3 multiplied by the whole of this becomes x to the power of 6 minus 2 to the power x minus x. And this is what we are having at this point. So we know that 2 to the power of 1 is the same thing as 2. So we can express the whole of this as 2 to the power of x divided by 2 plus x divided by 2 equals 3 multiplied by x to the power of 6 minus 2 to the power of x minus x. We should determine the value of x in this equation. So at the left hand side of this equation, we can see that the denominator of 2 to the power of x, the whole of this, is 2, and the denominator of this is 2. So since they both have 2 in common as the denominator, we can write this to be 2 to the power of x plus x divided by 2, which equals 3 multiplied by x to the power of 6 minus 2 to the power of x minus x. So from here, to eliminate these 2 here, we have to multiply through by 2. So if we multiply through by 2, then we'll be having 2 multiplied by 2 to the power of x plus x divided by 2, which equals 2 multiplied by 3 times x to the power of 6 minus 2 to the power of x minus x, at the exponent of x here at the right hand side of this equation. So these two cancels these two in at that point. So we are left with 2 to the power of x plus x at the left hand side of this equation, and this equals 2 multiplied by 3 equals 6. So we are having 6x to the power of 6 minus 2 to the power of x minus x. So this is what we are having at this point. So we have to recall the law that if we have x square, that this x square can also be written as e to the power of 2 ln x. We can see the exponent of x here, that this is 2, and the base is x, and this is expressed as e to the power of the exponent multiplied by the ln of the base. So if we apply this law at the right hand side of this equation, we are going to have 2 to the power of x plus x equals 6 then we apply this law, yeah, then we'll be having e to the power, recall we said e to the power of the exponent multiplied by the ln of the base, because this 2 is the exponent of x here and the base is x, so we are having e to the power of 2 multiplied by ln of the base x. So here we are going to have e to the power of the exponent, and the exponent is 6 minus 2 to the power of x minus x. So we are going to have e to the power of 6 minus 2 to the power of x minus x ln of the base. The base here is x, so we are having ln x. So this is what we are having at this point. So this can also be written as 2 to the power of x plus x equals 6 multiplied by e to the power of, we can factor this out, that is we are having 6 ln x minus 2 to the power of x ln x minus x ln x, and the whole of this is the exponent of e here in this equation. So this is what we are having at this point. So we need to continue to solve and determine the value of x in this equation to satisfy it. So at this point, we want to have 2 to the power of x plus x right here at the exponent of e. So we have to simplify the whole of this to have 2 to the power of x plus x at this point. So we see that if we simplify this, we can have something similar to 2 to the power of x plus x. That is, we are now having 2 to the power of x plus x, that this equals 6 multiplied by e to the power of 6 ln x minus, we bring out the bracket, 2 to the power of x plus x multiplied by ln x. So this is what we are having at this point, because this can be simplified to be the whole of this. So we can now recall the law of exponents. Recall that we said if we have a to the power of m minus n, that this equals a to the power of m divided by a to the power of n. That is the same base to the power of m minus n. Then it can be written or expressed in this form. So since this is 6 multiplied by e to the power of 6 ln x, recall e to the power of this minus this, we can say this is the m and this is the n. So let's express it in this form. Then we'll be having 6 multiplied by e to the power of 6 ln x divided by e to the power of 2 to the power x plus x, all multiplied by ln x. Recall that the whole of this is the exponent of e, and this is the exponent of e. This is the denominator and this is the numerator. So on the left hand side we are having 2 to the power of x plus x, and this is what we are having at this point. So we need to continue by multiplying through by e to the power of 2 to the power x plus x multiplied by ln x. This is at the exponent of e. So if we multiply through by the whole of this, then we'll be having e multiplied by 2 to the power of x plus x multiplied by ln x multiplied by the whole of this 2 to the power of x plus x, which equals e to the power of 2 to the power x plus x multiplied by ln x. This all multiplies 6 multiplied by e to the power of 6 ln x, all divided by e to the power of 2 to the power x plus x, all multiplied by ln x. And this is what we are having at this point, since we have multiplied through by the whole of this. And since this is common, this can cancel out. So we'll be left on the right hand side. This equation can also be written, the whole of this can be written as this at this point. So from here, we need to multiply through by ln x, because we see that at the exponent here, we are having this 2 to the power of x plus x all multiplied by ln x. And we have to apply the law that the Lambert W function of any expression in the form of a multiplied by e to the power of a equals a. So we want the exponent of e to be the same thing as this. That is, this and this must be equal. So whenever the expression is in this form and we are looking for the Lambert W function of any expression in this form, then it equals a. So we want this to be the same thing as this. So for this to be the same thing as this, we have to multiply through by ln x. So if we multiply through by ln x, then we are having 2 to the power of x plus x multiplied by ln x multiplied by e to the power of 2 to the power x plus x multiplied by ln x, and this equals 6 ln x. Recall we are multiplying through by ln x, so there was no ln x here, but since we've multiplied the left hand side by ln x, we have to multiply the right hand side by ln x. 6 ln x multiplied by e to the power of 6 ln x. Recall this was the law that the Lambert W function of any expression in this form equals this. So let's apply this law here. And for us to apply this law here, we have to take the Lambert W function of both sides of this equation. So if we take the Lambert W function of both sides of this equation, then we'll be having the Lambert W function of 2 to the power of x plus x all multiplied by ln x multiplied by e to the power of 2 to the power x plus x multiplied by ln x equals the Lambert W function of 6 ln x multiplied by e to the power of 6 ln x. So we can now see that the whole of this is the same thing as the exponent of e, and the whole of this is the same thing as the exponent of e here, as the whole of this is the same thing as the exponent of e, and whenever a number multiplies e to the power of that same number, and we are taking the Lambert W function of that expression, then it equals the number. So the whole of this will then become 2 to the power of x plus x multiplied by ln x. Since this is the same thing as this, and we are looking for the Lambert W function of the whole of this, then it equals this. When we apply this rule, this law, so this becomes 6 ln x. So we can see that ln x is common to both sides. Since ln x is not equal to 0, ln x is not equal to 0, so we have to divide through by ln x. So if we divide through by ln x, ln x divides through, then we are having 2 to the power of x plus x equals 6. Here we can see we have gotten to the point that at the left hand side of this equation we are having 2 to the power of x plus x, and this equals 6. So we are to determine the value of x at this point. So this can further be simplified to be 2 to the power of x, which equals 6 minus x. We have just taken x to the right hand side of this equation, and when this positive x crosses the equality sign, it becomes a negative x. Then we are having 2 to the power of x equals 6 minus x. So we have to divide through by 2 to the power of x. So if we divide both sides by 2 to the power of x, 2 to the power of x, then this can go through one time. Then we'll be having that 1 equals 6 minus x. The whole of this can be expressed as these 2 to the power of minus x. Recall the law, the reciprocal law, or the law of negative index, that if we have a to the power of minus m, that this is the same thing as 1 divided by a to the power of n. It was in this form, that is 1 divided by the whole of this, and we have just written it in this form. We have just applied the law of negative index. So we got this. So at this point, we are now having that 1 equals 6 minus x multiplied by 2 to the power of minus x. But we want the exponent of 2 here to be the same thing as the whole of this, that is 6 minus x. So we have to multiply through by 2 to the power of 6. So if we multiply through by 2 to the power of 6, then we'll be having 2 to the power of 6 multiplied by 1 on the left hand side of this equation. And on the right hand side of this equation, we are having 6 minus x multiplied by 2 to the power of minus x multiplied by 2 to the power of 6. So we have to apply the law that a to the power of m plus n equals a to the power of m multiplied by a to the power of n. So whenever two numbers are multiplying each other, that the base are the same, so we have to add the exponent. So we can see that the base are the same, so we have to add the exponents here. So this can further be simplified. We know 1 times any number is the same that number. So here we'll be having 2 to the power of 6 equals 6 minus x multiplied by 2. Recall we are applying the addition law of exponents. So this becomes 2 to the power of minus x plus 6. So we can further simplify the exponent of 2 to be 2 to the power of 6 equals 6 minus x multiplied by 2 to the power of 6 minus x. So this is the same thing as this. So now we are now having that the exponent of 2 is the same thing as the whole of this, which is 6 minus x. So we can recall the law that e to the power of ln x equals x. And if we have x to the power 2, that this is the same thing as e to the power of 2 ln x, that is e to the power of the exponent multiplied by the ln of the base. So let's just apply that rule here. So we'll be having 2 to the power of x equals 6 minus x multiplied by e to the power of the exponent. The exponent here is 6 minus x, 6 minus x multiplied by the ln of the base x, the base x here. So the base here is 2, base 2. So this is what we are having at this point. So we want the exponent of e to be the same thing as this, so that we can apply the Lambert W function. So for the whole of the exponent of e to be the same thing as the whole of this, we have to multiply through by ln2. So let's just multiply both sides of the equation by ln2. So if we multiply both sides of the equation by ln2, then we'll be having 2 to the power of 6 multiplied by ln2 equals 6 minus x multiplied by ln2 multiplied by e to the power of 6 minus x all multiplied by ln2. So this is what we are having at this point. So we still need to recall the law that the Lambert W function of any expression in the form of a multiplied by e to the power of a equals a. So we have to continue to apply this law here to solve this problem. So for us to solve this problem, we have to take the Lambert W function at both sides. So let's just take the Lambert W function at both sides. So we take the Lambert W function of 2 to the power of 6 ln 2 equals the Lambert W function of 6 minus x multiplied by ln 2 multiplied by e to the power of 6 minus x multiplied by ln 2. So this is what we are having at this point, that the whole of the exponent of e is the same thing as this. So we can call this, recall that we said the Lambert W function of any expression in this form equals this. So we can see that this can be written as a. We can take this as well to be a. So the Lambert W function of any expression in the form of a multiplied by e to the power of a equals a. And the a here, we are taking a to be 6 minus x multiplied by ln 2. So the whole of this can be written as the Lambert W function of 2 to the power of 6 ln 2 2 to the power of 6 ln 2 equals a which is 6 minus x all multiplied by ln 2. But for us to determine the value of x in this equation, we have to simplify the left hand side of this equation. So for us to simplify the left hand side of this equation, we need to take note of the fact that 2 to the power of 6 is the same thing as 2 to the power of 2 plus 4. So if we apply the addition law of exponent at this point that we are having 2 to the power of 2 plus 4, this can be simplified as 2 to the power of 2 multiplied by 2 to the power of 4. That is to say, we are having 4 multiplied by 2 to the power of 4. So the whole of this can be substituted in place of 2 to the power of 6. So let's substitute the whole of this in place of 2 to the power of 6 here at the left hand side of this equation. So then we'll be having the Lambert W function of, recall, we are substituting the whole of this in place of 2 to the power of 6 in this equation. So we are having the Lambert W function of 4 multiplied by 2 to the power of 4 all multiplied by ln 2 equals 6 minus x multiplied by ln 2. So we have gotten that the Lambert W function of the whole of this equals 6 minus x ln 2. So let's simplify this equation further. We have to simplify the left hand side of this equation. So here, this can be written as the Lambert W function of 4 multiplied by ln 2, because this is also multiplying. So this becomes 4 multiplied by ln 2. Recall that we said if we have x squared, that x squared is the same thing as e to the power of 2 ln x, the exponent multiplied by ln x all to the power of e. So let's apply that here for 2 to the power of 4. Let's say we have 2 to the power of 4, and this equals 6 minus x ln 2. So now let's apply this at the left hand side of this equation. So if we apply that at the left hand side of this equation, then we are having the Lambert W function of 4 ln 2 multiplied by e to the power of the exponent multiplied by the ln of the base, that is the exponent 4 multiplied by the ln of the base 2, and this equals 6 minus x multiplied by ln 2. So right here, we have to still recall the equation. We have to still recall this equation that we said the Lambert W function of any expression in this form equals this. That is, the Lambert W function of any expression in the form of a number multiplying e to the power of that same number. It can be a variable that it will be that same number, or the variable. So if we take this, apply this law here, that is, we take this to be a, and we also take the whole of this to be a, since they are the same, that a multiplied by e to the power of a, that the Lambert W function of any expression in such form equals a, that is the whole of this equals a, and the a here is 4 ln 2, and this equals 6 minus x ln 2. So we can see that ln 2 is common to both sides. So since ln 2 is common to both sides, we have to divide through by ln 2. So let's divide through the equation by ln 2. ln 2 cancels out. So we are having that 4 equals 6 minus x. So at this point, we have to make x the subject of the formula or transpose. So if we do so, that is, we take x to the left hand side and take all the constants to the right hand side of this equation. So then we are having that this is a negative x. So if we take it to the right hand side and it crosses the equality sign, then it becomes a positive x on the left hand side, and this equals 6, and we take the 4 to the right hand side of this equation, then it becomes 6 minus 4. And we know that 6 minus 4 equals what? 2. Therefore, the value of x to satisfy the original equation that we were given is 2. So we have to check whether the value of x really equals 2 can satisfy the equation that we were given. So we have to check for the value of x. And what were we given? Recall that we solved for the value of x from the initial equation. We have to recall the equation that we were given. We were given this equation here. That's 2 to the power of x minus 1 plus x divided by 2 equals 3 multiplied by x to the power of 6 minus 2 to the power of x minus x. So we have to substitute for the value of x in this equation, and if both sides of this equation are equal, then we have to know that x really satisfies this equation. So let's substitute for the value of x for the left hand side. We are checking for the left hand side of this equation. For the left hand side of this equation, so the left hand side, we are having 2 to the power of x minus 1 plus x divided by 2. So recall, we have to recall the value of x in the equation there. Let's go through to check what we had as the value of x in the equation. We have to recall the value of x. The value of x. We said x equals 2. So we have to recall that x equals 2. So let's substitute for the value of x at the left hand side of this equation, that x equals 2. So we are now having that the left hand side of this equation equals 2 to the power of x minus 1 plus x divided by 2. So if we substitute for the value of x, which is 2, then we are having that this is 2 to the power of 2 minus 1 plus 2 divided by 2. We know that 2 divided by 2 is 1. So definitely we are having that 2 to the power of 2 minus 1, this is 2 minus 1, and that becomes 1. So we are having 2 to the power of 1 plus this divided by this, which is 1. And 2 to the power of 1 is 2. So we are having 2 plus 1, which is 3. That is for the left hand side of this equation. So we have gotten that the left hand side of this equation equals 3. So if x really satisfies this equation, then the right hand side will also be equal to 3. Let's check. We are having that the right hand side of this equation, equals 3 multiplied by x to the power of 6 minus 2 to the power of x minus x. This is what we are having. Recall that this is not part of what this is a problem. So right here we are having that this multiplied by the whole of this is the right hand side of the equation. So we have to substitute for the value of x, which is 2. Then we are having the 3 multiplied by 2 for the value of x. We are now substituting 2 to the power of 6 minus 2 to the power of 2 minus 2. So 2 to the power of 2 is 4. So we can write this to be 3 multiplied by 2 to the power of 6 minus 2 to the power of 2, 4 minus 2. So this can further the exponent here. Minus 4 minus 2 is minus 6. So this can be written as 3 multiplied by 2 to the power of 6 minus 6. 6 minus 6 definitely equals 0. So we are now having 3 multiplied by 2 to the power of 0.